All right, we're going to continue our work with writing and graphing inequalities, and I have a bit of a challenge here that I want us to try to work on during this video. And I'll read through it. Suppose x is less than y, so that's a given statement. We know that is true. Does that mean that a times x is less than a times y for any value of a? Okay, so we're multiplying both sides by a. It kind of connects back to solving equations. I think we multiplied both sides by a number. And so does that keep our inequality true? If not, find a counterexample with values for a, x, and y. Okay, so let's think about this. What I want to do is just try a couple random numbers. So here, 3 is less than 5, x is less than y. And let's have a be, 10. Okay, so 3 is less than 5. That checks out. That's what we're given. That's good. Multiply both sides by 10. 30 is less than 50. Okay, cool. So it looks like that's true for at least some numbers. What if a was a fraction? Let's try that. So x again is 3. Whoops. And let's say y is still 5. And let's have a be a quarter. Let's see what happens. So of course 3 is less than 5. That still checks out. Multiply both sides by a quarter is 3 quarters less than 5 quarters. It still is, so it does check out here. So it looks like maybe we have something that might always be true, but I want to try to find some counterexamples here. I'm going to try a negative. Let's see what we get. So again, x is, let's actually have a few negatives in here. X is negative 5 and y is positive 7. And what if we multiplied by a negative 2? Let's see what happens. So negative 5 is less than 7. So that checks out. That's our given. That checks out. And let's multiply by negative 2 here. So 10 less than negative 14. Oh wow, it doesn't work. I wonder why that is. So I wonder if that's because x is the negative 5 or because a is the negative 2. And we'll actually learn in our next unit is that it's because of this a being negative. So this guy does not work. So we found a totally legit counterexample right there. I want to show you another counterexample. One thing we often look at with inequalities is we look at the boundary examples or the edge conditions. So, if x is less than or equal to y, what happens when x is exactly equal to y? And in this case, we've just found that, okay, we have some curiosity going on when a is negative, but what's that boundary condition? What's the edge? It's when a is 0. So let's see what happens there. So we have x is negative 5 again, and y is 7. And let's have a be 0. And so negative 5 is less than 7. That still checks out. And negative 5 times 0, we're curious, is that less than 7 times 0? Is 0 less than 0? No, it's not. 0 is equal to 0. So that doesn't work either. Okay. So it looks like we're developing perhaps a bit of a theory that this is not true. The counterexample or this hypothesis fails as whenever a is less than or equal to 0. So it looks like this is true as long as a is greater than 0. So that would be a caveat we would put on that. Okay, so there's our challenge, and that's a good place to stop right there.